So the concept of a vector might be a little bit challenging and confusing at the beginning. So I think it's very good we work at least a couple of examples to help us understand how it works. Look at this first example. We have airplane which flies to 20 kilometer at 60° north of east, which means this angle. So the blue would be our first leg. The angle of blue and east would be 60°. We'll often use x as east, and this is north, northeast. Okay, and then we have this airplane flies 150 kilometer, which is 30° north of east. So we want to find out what's the magnitude and the direction of the airplane's total displacement. That's our goal. So to do this, which means let's call the blue vector A. This is our vector A. And call the green vector B. Apparently, we want to find out what is A plus B. So the displacement in X, this is AX, and this is BX. So we will call the red R. Let's see, A has X component in the X direction and Y component in the Y direction. B has X component in the X direction, Y component in the Y direction. So R has Rx in X direction and Ry in Y direction. So how do we find Rx? Ax plus Bx. How do we find Ry? Ay plus by. So it turns out that we need to find what is ax, what is ay. So we need to do this. Ax is a cosine. Which angle should we use? The angle of A, which is 60°. Ay is a sine 60°. Now and then the magnitude of A is 220 kilometer, right? So you put this into calculator, you'll find AX is 110 kilometer. AY is 190.5 kilometer. Now we need to do the same for BX, BY. BX is B times cosine 30° this time. So it's 129.9 kilometer for BX. B sine 30° be 75 kilometer. So our X is 110 plus 129.9 kilometer, total 239.9 kilometer. Our Y is 190.5 plus 75 kilometer, 265.5 kilometer. So now we can find what's the magnitude of R by doing Pythagorean theorem, which gives, now put this into calculator, this gives us 357.8 kilometer. And the angle of R would be inverse tangent Ry over Rx. Put it into calculator again. So inverse tangent 357.8, 265.5, which give us 47.9 north of east. Okay, so those two are the final answer. How we solve this kind of problem. Yeah, try to work on it by yourself to get a grasp of this concept. Now let's move on to the second example. We have an airplane flies due west at an airspeed 425 miles per hour. The wind is blowing from northeast at 40 miles per hour. What is the ground speed of the airplane? What is the bearing of the airplane? Okay, so let's also do a graphic. Blue is speed of the airplane, 425 miles per hour due west. Wind is 40 miles due southwest. The wind blowing from northeast, right? So actually the wind is pointing to southwest with 45-degree angle. So to find the ground speed, we need to add blue and green together. So we need to do the same. We need to do the same thing, but this time let's call A is the speed of the airplane. AX is simple, is minus, and AY is 0. Right, the speed of the airplane in the y direction is 0. Now wind, the x component of the wind, 40 cosine 45 degree minus 228.3 MP hour. By 40 sine 45 degree. Now you would ask why I have a negative, right? So this is actually a good question. If I would write it, I would write it 225 degree for the angle of the wind, because if we go from 0, the angle of the wind is actually 225 degree. So you do this, you automatically get the negative. Okay, so now add that together, the speed, the x of the speed, the total speed, ground speed, add it up. Y component of ground speed, so the ground speed calculated by Be-Socrates theorem will be 454.2. And the bearing angle we need to calculate using, see, this is a ground, this is a ground, this is the bearing. So we need to find this angle, this small angle between blue and red. So we need to do a inverse tangent of 28.3 over 453.2, and this angle gives us 3.6 degree. And then the bearing, of course, is, and on a campus, compass west is 270 degree. So the bearing actually is 270 minus 3.6 equals 266.4 degree. That's the answer.